All right, so here we're going to look at the mean and standard deviation of a binomial probability distribution. These formulas are on your pink sheet, so make sure that you identify those and you know where they are. Here we use the mean of x, mu of x, and here we use the standard deviation of x. So there's our symbols for that. So where are we going to use this? Here's an example. If the LHS basketball team is expected to win 70% of their games, how many games would you expect them to win during a 50-game schedule? So expect is another word for mean, or what would they average? And logic tells us that they would win 70% of their games. So the mean of x, if we go by the formula, is 50 times 0.7, which is 70% of their 50 games, which is 35 games. So hopefully that is logical as well as easy just to use the formula. So now how much error would you expect? This is standard error or standard deviation. What kind of error would we expect? How far would we swing from the 35 games? So here we use our other formula. Standard deviation of x is the square root of 50 times 0.7 times 1 minus 0.7, which is 0.3. And that is 4.95. So we wouldn't be surprised if we were as far off as 5 in either direction from the 35 games that we would expect them to win. Okay, binomial distribution will be normal, or we can use the normal approximation when n is big enough. Okay, so your first question should be then, what is big enough? How big should n be? How large should n be? Okay, so as n increases, the binomial distribution with n and p gets close to a normal distribution with np is the mean. There's your formula for mean of x. And square root of np times 1 minus p, which is your standard deviation of x. So there's your mean and your standard deviation. So how big should n be? This is your big rule of thumb right here. This is what you need to check if you're going to use the normal approximation. You need to check that n times p is greater than or equal to 10, so the number of successes is greater than or equal to 10, and the number of failures are greater than or equal to 10. So let's just make sure that for Chapter 8, for these purposes, that you're using the normal approximation when you're told to use it. But then after this, you can use it anytime you want, as long as n is big enough and you show that you have checked this. Okay, you have to show that you're checking it, and so therefore you can use the normal approximation. So now let's go ahead and do that. An Olympic archer is able to hit the bullseye 80% of the time. Assume each shot is independent of the other. She shoots 200 arrows in a large competition. So x is binomial because she either hits the bullseye or she doesn't. So x is a binomial distribution with a mean of 200 and a standard deviation, with a n of 200 and a p of 0.8. Getting ahead of myself. Okay, so what are the mean and standard deviation of this binomial? So the mean of x is going to be np, which is 200 times 0.8, 80% of 200, which is 160. There's your mean. And then the standard deviation of x is going to be the square root of 200 times 0.8 times 0.2, which is about 5.7. So there's the mean and standard deviation of the binomial, which could potentially be used for the normal approximation. So what we are checking here is that first rule of thumb, where we said that n times p is greater than or equal to 10. So n is 200, p is 0.8. We need to know if that's greater than or equal to 10. Well, that is 160 greater than or equal to 10. Yes, this checks out, this works. Okay, so now we're going to do the successes, or the failures. So n times 1 minus p must also be greater than or equal to 10. So 200 times 1 minus p will be 0.2, must be greater than or equal to 10. So 40 is greater than or equal to 10, which obviously it is, and therefore, yes, we can use the normal approximation. So now we're saying that X could also be normally distributed with a mean of 160 and a standard deviation of 5.7. So would we be surprised if she made only 140 bullseyes? Well, let's draw that as a normal distribution. So we start in the middle here with our mean of 160, and we go out a standard deviation in each direction of 5.7. And so here is our 1, 2, and 3 standard deviations away. So would we be surprised if she made only 140 bullseyes? Yes, we would be super, super surprised, because this is way below the mean with respect to the standard deviation. We are more than 3 standard deviations below the mean. So yes, we would be surprised if she only made 140 bullseyes. So yes, we would definitely be surprised if she made only 140 bullseyes, because 140 is more than 3 standard deviations below the mean. So that is using the binomial distribution, finding a mean and standard deviation. Here's examples of why you would use the mean and standard deviation. Or you can take it even further, that if this rule of thumb is satisfied, then the binomial can actually function as a normal distribution, of course, as long as n is large enough. And here's how we check that. And you always show it and you always check it. So that is all for this. Have a great day.